I'm going to talk about a random variable now, and it is a numerical measure that measures probability from a given experiment. So as an example, we could flip a coin 3 times, and each time we do it, we're going to count the number of heads that we observe. And that number is going to be what the random variable x is. Now x is going to have 4 different possibilities in that case. It could be 0, 1, 2, or 3. Each one of them is distinct, and each one will have a probability. This is a discrete random variable. And discrete random variable means that you have a given probability at each possible point. Now they don't have to be integers, but in each case you've got a probability for each value. The difference between discrete, which are basically countable even if it's a very large amount, even in the billions, if we can count them, it'll be discrete. Difference between that and continuous is a continuous is where the entire thing, every single point in between each other points, and we have an infinite amount of numbers in between any two numbers. That'll make it continuous. Continuous things are like time, volume, weight, that sort of thing. Now, in some of these, you could always measure things to the nearest second, or to the nearest pound, or to the nearest mile per hour if you're talking about speed, and make them discrete, but those values in and of themselves are continuous. Alright, so we're going to try, in this example, try to determine whether or not the setup when we're talking about a discrete or continuous random variable. For part A, we're looking at the number of light bulbs that burn out in a room of 10 light bulbs in the next year. Well, the possible values we could have are 0, 1, 2, 3, all the way up to 10. So we can count those. That will constitute a discrete random variable. The only values are 0 all the way up to 10. Part B, the number of leaves on a randomly selected oak tree. Now this could be dozens, hundreds, thousands, I don't know how many leaves are on a given tree, but it's going to be a very large number. It's either going to have no leaves or it's going to have a number of leaves. So this will also be discrete. And this is illustrated by, it could be 0, 1, 2, and the dot, 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 and indicating that it's going to go on in this manner until we find the actual value. Even if we're talking about something that happens in great number in the course of a day, say we maybe take an example of the number of cans of soda pop sold in a given day. It could be in the millions or billions. We can still count that high. Now, if we're looking at the volume of soda sold, that would be a continuous distribution, as the volume is a continuous entity. Part C will illustrate this as well. The length of time between calls to 911. This is time, and that value will be greater than 0, but any number other than that. So time is a continuous function, so this will be continuous.